everyone. I'm Mike. I'm the co-founder of an open source observability tool called HyperDX, and I currently lead the ClickHouse observability product efforts today as well. And today I'm going to talk about why columnar databases are a pretty dang good fit for observability data in general. But before I get into that, I want to talk a little bit about the history of observability tools, or at least an incredibly compressed version of that. So I think the first observability tool, at least for software, really starts with grep, where you can go onto a single server back then, grep your logs, find the error that you're running into, and then you can solve your incident. But over time, we started adding more servers beyond a single one, and SSHing into every one of them got a little bit difficult. So we had tools like Splunk, centralized in one place. You go to one place, find all your logs, and you're good to go. Then we kept adding more and more servers, more and more logs. Applications got more complex. We added tools like Elasticsearch, made searching logs quite easy as well. At the same time, though, we started wanting to understand trends of data over time, understanding how many errors are we occurring, what CPU usage, et cetera, et cetera. Introducing tools like Graphite that's really good at time series. And then as we went into the cloud, had more elasticity around our compute, we weren't just having machines racked into our data centers anymore. We needed more higher cardinality. Prometheus came around with its dynamic labels, which made that quite good. And then cardinality and volume kept increasing, and tools like Thanos came around to help with that as well. So over time, it seemed like every time we increased cardinality and volume, we needed a new data store to help us with storing our observability data. So the question is, what's next? What could be the next data store that'd be quite good for observability? Obviously, it kind of gave away at the beginning, but we think that properties are things like being really cost efficient, really fast at searching, lightweight indices, great at aggregations as well, so you can find out trends of your data over time, not just finding individual events. And it also should be built ideally on top of object storage, so that's really cheap and has like an infinite bucket of where you could put data into. And back when I was building HyperDX, an observability tool, we looked around in terms of, hey, what are other companies doing today? And we found teams like Netflix and Anthropic using columnar data stores actually for their next generation observability tooling. ClickHouse in particular, because it is probably one of the most popular columnar databases, at least the open source columnar databases today. And why would they pick columnar databases? It's because columnar databases have a lot of really interesting properties around them. So if you're not familiar with a columnar database, instead of having your traditional row type database, like if you use Postgres for instance, we actually split different properties or columns into its own files effectively. This is really helpful because generally when you're looking at your data, you're only operating on a subset of properties. You're not trying to aggregate across every single field within your wide event, for example. You're only looking at specific fields like duration, host, region, et cetera. So this helps reduce I/O. It also gives you a lot of compression benefits when you start sorting them. And overall, it just makes your resource utilization a lot more efficient when you're querying this data. It also allows for really neat properties, such as a sparse index. So instead of building a really dense index where you have, for example, every term mapped to every single document or line of log, you can actually build indices where you only point into every couple thousands of logs. And this allows you to build an index that instead of taking up terabytes or petabytes for an index, it actually only takes megabytes or gigabytes, which is, again, quite good for efficiency. Last of all, a lot of these column stores are relatively new, and they're built generally on top of object storage or native on top of object storage as well. There's a ton of benefits to this. Object storage is relatively cheap, it's relatively infinite, and it's also quite durable. So you kind of don't have to worry about durability of your system. And you can kind of have stateless databases on top of it to be able to read and write data without having to worry about maintaining disks that are local to the machine itself. So you get a lot of cost efficiency and flexibility on top of your database. And of course, on top of that, a lot of these databases tend to be pretty good with integrations, integrating with things like OpenTelemetry, of course, visualization tools like Grafana, or my favorite, of course, HyperDX, my own project. But a lot of other tools as well are compatible with these databases, and they also tend to be open source, so they're quite extensible on top of that. And I know I only have a few minutes on stage today, but there's a ton of reasons I'd love to get into when it comes to columnar source for observability data. So if you do have a chance later today, please come say hi. We're right outside today, and then later this week, we're on booth 130. And later tonight, we also have an event where we have free food and drinks, no talks, so just good conversations with that. But thanks so much.